So in this section we start with unit digit. Now what will we do in this? I'll give you any number and that any number will be raised to any number, and you need to tell me what is the unit digit of that. So any random number raised to any random number, what will be the unit digit of that number? Okay, so for example 4 raised to 343, tell me the unit digit of this. 5 raised to 512, tell me the unit digit of this. Similarly 9 raised to 2018, 7 raised to 2030, 8 raised to 2012, and then so on. So I'll give you any number raised to any number, you need to tell me what is the unit digit of that. Now if you can imagine, these numbers are extremely big numbers. What will be 4 raised to 343, very big number. 6 raised to 216, very big number. I'm not asking you the entire number, just the unit digit of that number. Okay, so how will you find this out? Okay, you don't need to find the entire number, only the last digit. So what is the process to find the last digit? Okay, so let's take one problem at a time. So first we'll start with this, say 2 raised to 20. Okay, I need to find the unit digit of this. Is there any pattern in this? Let's understand. Let's first find it out. What is 2 raised to 1? What is 2 raised to 1? That is equal to 2, correct, we know that. If I increase the power of 2 to 2, what is 2 raised to 2? That is equal to 4. Okay, if I increase the power, that is 2 raised to 3, that is equal to 8. If I again increase the power, I make it to be as 2 raised to 4, then the unit digit of this is 6. Okay, it is 16. And now I am writing only the unit digit of the power. So 2 raised to 1 2, 2 raised to 2 4, 2 raised to 3 8, 2 raised to 4. It is 16, but the unit digit is 6. That's what I write it here. Now let's take one more. 2 raised to 5. What is 2 raised to 5? 32. But as I told you, I'm writing only the unit digit, so I'll write it 2. What is 2 raised to 6? 2 raised to 6 is 64. So the unit digit is 4. What is 2 raised to 7? 2 raised to 7 is 128. So the unit digit is 8. And what is 2 raised to 8? 2 raised to 8 is 256. So the unit digit here is 6. If you can see, there is a pattern here. The unit digit of 2 gets repeated after every 4 power, which means 2 raised to 1 is 2. 2 raised to 5 is also equal to 2. And if I take the next power, which is, say, if I add 4 to 1, it gives me 5. If I add 4 to 5, that will give me what? 2 raised to 9. And that will also have a unit digit of 2. Because there is a cyclicity. After every 4 power, the unit digit gets repeated. Which means 2 raised to 1, 2 raised to 5, 2 raised to 9, 2 raised to 13, 2 raised to 17. All will have a unit digit of 2. Similarly, you can apply it here as well. 2 raised to 2, add 4 to that, you will get 2 raised to 6, which will be having both of them as a unit digit of 4. Next, what number will be 2 raised to 10? How do I know that? Add 4 to 6. Add 4 to 6, you get 2 raised to 10. That is also going to have a unit digit of 4. Similarly, your next number, that will be 3 plus 4 will give you 7. 7 plus 4 should give you what? 7 plus 4 should give you 2 raised to 11. 2 raised to 11, and this series is going to have a unit digit of 8. Similarly, 2 raised to 4, 2 raised to 8, and next 2 raised to 12. All will have a unit digit of 6, and that's how simple it is to analyze. So there are only 4 unit digits which you can get with any power of 2. And they are what? They are either 2, 4, 8 or 6. And then this 4 unit digit gets repeated after every 4 power. And I know the pattern as well. 2 raised to 1, 2 raised to 5, 2 raised to 9, 2 raised to 13. All will have a unit digit of 2. What do I understand from this? This is called as cyclicity. Okay, what is cyclicity now? The cyclicity of 2 here is equals to 4. What is the meaning of this? After every 4 power, the unit digit gets repeated. So now if I give you any random number, say 2 raised to 14, and I am telling you, tell me what is the unit digit of this. What will you do now? You know the cyclicity of 2, that is equal to 4. So divide this by 4. this power of 2, divide this by 4. Check the remainder. Okay, 4 3s are 12, remainder is 2. Check the remainder. So it turns out to be 2 raised to 2. Which means what? I convert this 2 raised to 14, whatever my big number is, in terms of this number. Because I know in the end only this 4 unit digit, either it will be 2 or a 4 or a 8 or a 6. Only this 4 unit digit will be there, any one of them will be there. So I convert whatever the bigger power is given to me, 2 raised to 14, into this smaller power, 2 raised to 2, which means it will come in this line. It will come in this line, if you can imagine it here. Next number will be 2 raised to 14, right? 2 raised to 10 ke baad it will be 2 raised to 14. So I know that it will come in this line. So this is similar. 2 raised to 14 is similar to 2 raised to 2. 2 raised to 2 ends in a 4. So 2 raised to 14 will also end in a 4. I got my answer. In case they give me 2 raised to 15, tell me what is the unit digit of this. Divide this by 4. What is the remainder that you get? 4 3s are 12, 13, 14, 15. 2 raised to 3, which means 2 raised to 15 is equivalent to 2 raised to 3. 2 raised to 3 ends in an 8. So 2 raised to 15 will also end in an 8. Okay, so it doesn't matter how much big a number you give it to me, I always convert it into this numbers. 2 raised to 1, 2, 3 or a 4. If you divide anything by 4, the remainder could be what? 1, 2, 3 or 0. 1, 2, 3 or 0. So when you get remainder as 2, you know what is the answer. When you get remainder as 3, you know what is the answer. If it would have been 2 raised to 13, again you would have divided this 13 by 4. 4 3s are 12. What is left is 2 raised to 1. So this will end in a 2. So 2 raised to 13 is similar to 2 raised to 1. Both of them will end in a 2. Right, so when you get 1 as a remainder, you know what is the answer. When you get 2 as a remainder, you know what is the answer. When you get 3 as a remainder, you know what is the answer. What if it is 2 raised to 16 and I am being asked what is the unit digit of this? Divide 16 by 4. What is the remainder? Remainder is coming out to be 0, which means this is similar to 2 raised to 4. 2 raised to 4. 2 raised to 4 ends in a 6. So this will also end in a 6. This will also end in a 6. Which means what? No matter how much big I give it to you, since 2 is a cyclicity of 4, which means after every 4 power the unit digit gets repeated, I'll divide my power 2 raised to any number. If I give it to you, you will divide this any number by 4. Okay, after that what will you do? You will check the remainder. So this is 2 then raised to remainder what is being there. Since you are dividing it by 2, remainder could be what? Remainder could be 1 or a 2 or a 3 or a 0. Right? These are the only 4 remainders that you can get when you divide a number by 4, because it has to be lesser than 4. When remainder is 1, this is the answer, 2 raised to 1. It means it will come in this line, it will go in this line. Your number is in this line. So that's why the answer is 2. If you get 2 as a remainder, this is the answer. It will be in this line. So your answer here is 4. The unit digit of that number will be 4. If you get 3 as a remainder, then this is the answer. 2 raised to 3, that is 8. It will come in this line. And if you get 0 as a remainder, this is the answer, which means this number will lie in this line. Okay, and the unit digit will be 6. In short, no matter how big I give you this number, you always convert this number into this form, 2 raised to 1, 2, 3, 4, because it has to be any one of this 4 digit, 2, 4, 8 or 6. It doesn't matter how much big the number is, because the unit digit always gets repeated, and they get repeated in a pattern of cyclicity of 4. Okay, so I always convert it into this smaller form, because for this I already know the answer. So I compare जो भी बड़ा नंबर दिया है वो इस नंबर के फॉर्मेट में किस लाइन में लाई करेगा. ओके, because my 2 is a cyclicity of 4. So similarly now I can find it out. What is 2 raised to 20? Divide this 20 by 4. 4 1s are 4 5s are 20. Remainder here is equal to 0, which means if remainder is 0, then last wala case 2 raised to 4, right? 2 raised to 4. This is equivalent to 2 raised to 4. 2 raised to 4 ends in a 6. So 2 raised to 20 will also end in a 6. And I got my answer. So the unit digit of 2 raised to 20 is 6. Okay, so remember this concept of cyclicity. Since the unit digit gets repeated, we need to find out only the basic unit digit of 2 raised to 1, 2, 3, 4. That's it. And after that it will be repeated. You just need to find out if that big number, if I have to put it in a cycle, which unit digit will come as a unit digit of that big number. Okay, so follow the simple process and you will always reach to your answer. Now let's understand 3. So after 2, let us understand 3. Is there any pattern finding out the unit digit of 3 raised to 50? Okay, so as we did it for 2, let us find out if there is any cyclicity pattern that we can find it for 3 as well. So what is 3 raised to 1? 3 raised to 1, we know it is 3. 3 raised to 2, let's find it out. This 3 raised to 2 is nothing but 9, we know that. Then 3 raised to 3 is what? 27, so the unit digit here is 7. And 3 raised to 4 is 81, so the unit digit here is 1. That's what I get it from this. What is 3 raised to 5? 3 raised to 5 is 243, which means what? The unit digit is getting repeated just like 2. It has a cyclicity of 4. 3 raised to 6, 3 raised to 7, 3 raised to 8. What will happen with this then? 6, 7, 8. The unit digit will be repeated. After 3, I am going to have a 9, because 3 raised to 6 is nothing but 9 into 9 into 9, 729. So my unit digit here is 9. 3 raised to 7 will have a unit digit of 7, and 3 raised to 8 will have a unit digit of 1. In case you don't know what is 3 raised to 5, 3 raised to 4, you don't need to know that. Just multiply the previous number by 3. 3 into 3, 9. 9 into 3, 27, 7 year. 7 into 3, 21, 1 year. 1 into 3, 3. 3 into 3, 9. 9 into 3, 27. 7 into 3, 21, and then so on. So you don't need to know the big number, because we are just playing with the unit digit here. So what do I understand from this? 2 has a cyclicity of 4, and so does my 3 has a cyclicity of 4, just like 2. So here also the cyclicity is equal to 4, which means what? After every 4 power, my unit digit gets repeated. So 3 raised to 1, add 4 to that, 3 raised to 5, and add 4 to that, 3 raised to 9. All will have a unit digit of 3. That's what I understand from this. Okay, similarly I can put what here? 3 raised to what? 3 raised to, it will be 2 plus 4, 6, 6 plus 4, 10. So what am I doing it here? Just adding 4 to this. 2 plus 4, 6, 6 plus 4 is equals to 10. All will have a unit digit of 9. Similarly, I can go for 3 raised to 11 and then 3 raised to 12. It will just be repeated like that. This will have a unit digit of 7 and this will have a unit digit of 1, and that's how simple it is. So after every 4 power, the unit digit is getting repeated. So I need to find this out now. Say 3 raised to 16. What will I do? Divide this 16 by 4. Okay, now check it, the remainder. What is the remainder that is coming out to be? Remainder is turning out to be 0. If the remainder turns out to be 0, which case do we follow? We follow the last case. Where did we learn this? In the powers of 2, right? So this will be similar to 3 raised to 4. 3 raised to 4 is a unit digit of 1. So 3 raised to 16 will also have a unit digit of 1. And that's how simple it is. So now I am being given as 3 raised to 50. Okay, what will I do? I'll divide this 3 raised to 50 by 4. Whatever is the cyclicity, you divide by that number. Check the remainder now. If I check the remainder, what is the remainder coming out to be? 4 ones are 4, 10, 12 fours are 48. Okay, so the remainder comes out to be 2. So this is similar to 3 raised to 2. 3 raised to 2 ends in what? 3 raised to 2 ends in 9. So this will also end in 9. So the unit digit of 3 raised to 50 is nothing but 9. That's how simple it is. Okay, so just like 2, you have to perform the same operation here. So if it is 3 raised to any number, you have to divide that any number by the cyclicity of 3, which is nothing but 4. Get the remainder. Get the remainder. Okay, that is very important to us. Get the remainder. Remainder can be any one of what? Remainder can be 1 or a 2 or a 3 or a 0 because you are dividing by 4. If the remainder is 1, this is the answer. If the remainder is 2, this is the answer. Remainder is 3, this is the answer. Remainder is 4, last one is the answer. In short, no matter how big the number is, we take it out in terms of 3 raised to 1, 2, 3, 4. Okay, because after every 4 power, the unit digit gets repeated. Okay, so it can be any one of 3, 9, 7 and then 1. I need to find out which of the 4 is the unit digit of that big number. So I take it out in terms of this number because I know everything will be part of this line or a this or a this or a this. Okay, it can be any one of this, and that's what I find out by knowing the concept of cyclicity. So after checking the cyclicity of 2, 3, 7 as 4, let us now come on to 8. Okay, we know the cyclicity of this 3 is 4. Let us now come on to 8 and check what is actually the cyclicity of 8. You can pause the video here and check it by yourself as to what is actually the cyclicity of 8. So let's start here. 8 raised to 1 is what? 8 raised to 1 is 8. We all know that, very simple. 8 raised to 2. 8 raised to 2 is nothing but 64. So the unit digit here is 4. 8 raised to 3 is nothing but 5 and 2. So unit digit here is 2. 8 raised to 4, 8 to the, it will be 16, so it will be 6 here. In case you don't know, just multiply this. 8 into 8, 64, 4 here. 8 into 4, 32, unit digit 2 here. 8 into 2, 16, unit digit 6 here. Then 8 into 6 will be 48. So again, 8 raised to 5, I am getting the unit digit as 8. 8 raised to 6, it will again be 4. 8 raised to 7, it will again be 2. And 8 raised to 8, it will be 6, and that's where I get a pattern. So just like your 2, 3 and 7, even 8 has a cyclicity of 4, which means after every 4 power, the unit digit gets repeated. So 1, add 4 to that, 5. Okay, add 4 to that, 9. So 8 raised to 9 will have unit digit of 8, and then so on, just like the previous problems. Which means what? If I give you 8 raised to any number, okay, 8 raised to any number, what will you do with that? You will divide that number by 4. Okay, then get the remainder out of it. So what will be remaining is 8 raised to the remainder. Since you divide it by 4, what are the possible remainders that you can get? Is 1, 2, 3 and then 0. So if you get remainder as 1, this is the answer. Remainder as 2, this is the answer. Remainder 3 and then remainder 0. In short, no matter how big number I give it to you, you always get it in terms of 8 raised to 1, 2, 3, 4, because the unit digit will be repeated after every 4 power. So no matter how big the number is, it needs to have one of this 4 unit digit, either a 8 or a 4 or a 2 or a 6, and that's what I check. In which line is the number lying? Is it in this line? Line number 1, 2 or 3 or 4. That's what the remainder tells me. So what will I do it here? 8 raised to 2012. That is the number that is being given to me here. I'll divide this number by 4 because 8 has a cyclicity of 4. Then check the remainder out of it. 8 raised to what? Divide only the last 2 digits. Why? Because we had learned this is the divisibility test for 4. That's what I apply. Last 2 digits. 4 3s are 12. Remainder is 0. Remainder is 0 means it is equivalent to last wala case. This is 8 raised to 4. 8 raised to 4 ends in a 6. So that's it. That's my final answer. 8 raised to 2012 will also end in a 6. Okay, so that's what you do it here as well, because the unit digit get repeated after every 4 power. Okay, so you just play with the cycle of 4. In case you want to imagine this, how is this happening, visualize this. Since this is last of the 4 cycle that we have been seeing, 2, 3, 7 and then 8. These are the 4 numbers who have a cyclicity of 4. So you need to remember this now. 2, 3, 7 and then 8. Okay, that's the 4 number which have cyclicity of 4. And in case you want to visualize, what are we doing? We are just playing with the multiples of 4, which means 1, 2, 3 and then 4. 4 2s are 8, 4 3s are 12. So as I am playing with the multiples of 4, it means what? 4 1s are 4, 4 2s are 8, 4 3s are 12. Obviously I'll get all of them remainder as 0, and all of them are going to have a unit digit of 6. Okay, if you have a 3 or a 7, it is one and the same thing, because if I take out one cycle of 4, what will be remaining is 3. So in this 7 I take out one cycle of 4, so what is remaining is 3. Okay, if you take 8 raised to 11, I take out 2 cycle of 4, 4 2s are 8. Then I see what else is remaining, 3 more is remaining here. Okay, so this is equivalent to 8 raised to 3. In short, no matter how many cycles of 4 are being given to you, okay, if it is 20, 12, imagine how many, whatever is the quotient that you will be getting is the number of cycle of 4 that you are taking it out, and then eventually you are saying that okay, this part is that does not fit into my cycle of 4. Okay, so that's an odd part that I'll take and compare it with the first cycle to reach to the answer. Okay, this is how you visualize it. In case you cannot visualize this, remember a trick which I told you: divide by 4, get the remainder, check the remainder to reach to your final answer. So after knowing the cyclicity of 2, 3, 7 and then 8, the cyclicity of them is 4, which means after every 4 power the unit digit gets repeated. Let's see the cyclicity of 4 now. 4 number, which is, I need to find out what is the unit digit of 4 raised to 343. Okay, so just like we did it for 2, 3, 7 and then 8, let's do it for 4. As you can see, I changed the color here. For 2, 3, 7 and 8 we have red color because all of them have a cyclicity of 4. What is with 4? 4 does not have a cyclicity of 4, and that's why there is a change with color here. Okay, what is 4 raised to 1? 4 raised to 1 is equals to 4, correct. What is 4 raised to 2? 4 raised to 2 is equals to 16. The unit digit here is 6. What is 4 raised to 3? 4 raised to 3 is equals to 64. Unit digit of 4. 4 raised to 4 will again have a 6. 4 raised to 5 will have a 4. 4 raised to 6 will have a 6, and then so on. It will just keep going like this. Okay, if you can check it, simple. 4 into 4, 16. 6 4s are 24, 4 here. 4 4s are 16, 6 here. 6 4s are 24, unit digit 4 here. So what do I understand from this? This 4 has a cyclicity of 2. Has a cyclicity of 2, which means after every 2 power the unit digit gets repeated. So this is 1, add 2 to that, 3. This is 3, add 2 to that, 5. This is 5, add 2 to that, 7, which means all of them are going to have a unit digit of 4. Similarly, you can apply it, add 2 to 2, it becomes 4. Add 2 to 4, it becomes 6. Add 2 to 6, it becomes 8. Which means 4 raised to 8 is going to have a unit digit of 6. That's what we understand from this. So what did we do there? If I give you 3 or a 7 or a 8 or a 2 raised to any number, what did you do there? You divided that any number, that was the power of 2, 3, 8 or 7, you divided that any number by equal to 4. Why did you divide the number by 4? Because it has a cyclicity of 4. All the 4 number had a cyclicity of 4. Okay, so you take out all the cycles and say what is remaining that does not fit into the cycle, and then you eventually reach to your answer. Or to say it in simple word, you just find out the remainder in this case. Right, you find out the remainder in this case, and that remainder tells you the answer because you compare it within the first column that we get it here and check which line is it coming. Now what will you do? This is 4 raised to 343. So what will you do? You will divide this entire number by what now? 2. Why not 4? Because in this case it has a cyclicity of 2. And you always divide the power by the number by its cyclicity. So it has a cyclicity of 2. That's why you divide it by 2 and not by 4. Now get the remainder out of it, just like you did it earlier. So what is the remainder here? The remainder here will be 1. The remainder here will be 1. Okay, what are the remainder that you can get from this? If you divide any number by 2, what are the remainder that you will get? You will get only 2 remainder. You will get something that is less than 2, that is 1. And if it is divisible by 2, you will get a remainder of 0. So if you get remainder 1 as an answer, this is your answer. That is equals to 4. 4 raised to 1 is 4. If you get remainder as a 0, which means 6 is your unit digit, and that's how simple it is. Because if it is divisible by 2, it will be 2, 4, 6, 8. It will always be divisible by 2. So whatever is divisible by 2, you will always guess the last of it, which is giving me a unit digit of 6 here. That's how simple it is. And you reached your answer now. Okay, there is one more pattern to this as well. 4 raised to odd number and 4 raised to even number. Since this has a cyclicity of only 2, we can apply a simple logic here as well. Whenever 4 is raised to any odd number, check it, 1, 3, 5, 7, the unit digit has to be 4. And whenever 4 is raised to any even number, okay, what is an even number now? 2, 4, 6 and then 8, which means it is divisible by 2, then the unit digit will always be equal to 6. And you can just check it here, it is an odd number, the unit digit has to be 4, no need to divide here as well. Because this is a cyclicity of 2, it becomes further easier to reach to the solution of this. Let's take the next number, which is 9. Let us find out the cyclicity of 9. If you can see it here, 4 and 9 both have a blue circle here, which means both will be having a cyclicity of 2. Let us just verify if 9 has a cyclicity of 2 here. So 9 raised to 1 is equals to 9. 9 raised to 2 is equals to 81, so unit digit is 1. 9 cube 729, unit digit 9. 9 raised to 4 is 81 into 81, unit digit 1, and then so on. So this verifies that 9 has a cyclicity of 2. 9 into 9, 81. 1 into 9, 9. 9 into 9, 81. 1 into 9, 9, and then so on. Which means just like 4, if I give you 9 raised to any number now, what will you do? You will divide that number by 2. Okay, check the remainder. 9 raised to the remainder. Remainder could be what? It could be 1 or a 0 as you are dividing it by 2. If remainder is 1, this is the answer. If remainder is 0, this is the answer. It's okay. So just like the previous one, we take it out in terms of this column. We compare it with this. No matter how big the number is, we take all the cycles of 2 side, then we see what is not fitting into the cycle, and eventually you reach to this as an answer. And I also told you the shortcut of this. Since there is a cyclicity of 2, so 9 raised to even number and 9 raised to odd number is all that you will have to see it here. Okay, 9 raised to odd number. If it is 9 raised to even number, which means it will always end in a 1, 2, 4, 6, 8, and then so on. And if it is 9 raised to any odd number like 1, 3, it will always end in a 9. So just remember 9 raised to 1 and 9 raised to 2. What is that? And you will get the answer for all of them. So let's just check it here now. 9 raised to 2018 is what I have. I'll see, is this an even number or an odd number? It's an even number. If it's an even number, it will end in what? 1. So 9 raised to 2018 has a unit digit of 1. That's how simple it is. So from this section, just remember what is the cyclicity of 2, 3, 7 and then 8, 4. What is the cyclicity of 4 and then 9? 2. What are we doing it here? No matter how much big a number give it to you, you take it out in terms of the power of 1, 2, 3 or 4 depending upon their cyclicity. You simplify it, you take up all the rest of the cycle aside, you make sure what is remaining, that is not the part of cycle, you derive it in terms of first column and then reach to your answer. Now let us just check the cyclicity of the 2 remaining numbers here. One is 6 and the other one is 5. We put a green circle to both of them, which means both of them have same cyclicity. What is actually their cyclicity? It is quite simple to understand. 6 raised to 1, the unit digit is 6. 6 raised to 2, 36, unit digit is 6. 6 raised to 3, 216, the unit digit is 6. In short, if you just keep on multiplying 6 into 6, 36, 6 into 6, 36, 6 into 6, 36, so 6 raised to anything. 6 raised to anything or any number, the unit digit will always be 6. The unit digit will always be 6. So 6 raised to 1 crore, the unit digit will be 6. So 6 has a cyclicity of 1, which means after every 1 power the unit digit gets repeated. So 1 plus 1 2, 2 plus 1 3, 3 plus 1 4. Always 6 raised to anything, you can say the unit digit will always be 6. So 6 raised to 2 and 6, anything, the unit digit will always be equal to 6. And so does your 5, has a similar pattern. Check it out. 5 raised to 1 is equal to 5. 5 raised to 2 is equals to 25, unit digit is 5. 5 raised to 3 is equals to 125, unit digit is 5. 5 raised to 4 is equals to 625, unit digit is 5. In short, if you keep on doing it like this, find to 5 25, find to 5 25, find to 5 25, and then so on. So if I give you 5 raised to anything, 5 raised to anything, the unit digit of this always has to be equal to 5. So just like 6, even your 5 has a cyclicity of 1, which means 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, 4 plus 1 5. All the powers of 5 will always have a unit digit of 5. That's how simple it is. In fact, you can find it out the last 2 digits here. Okay, if it is 5 raised to 2, the last 2 digits will be 25. There are only 2 digits here. But if it is 5 raised to 3 as well, the last 2 digits will be 25. It's 125, but the last 2 are 25. This is 5 raised to 4, 625. The last 2 digits are 25. So 5 raised to anything, the last 2 digits will always be 25, unless it's 5 raised to 1, that is 5. But rest in all the cases, it will always be 25. So you can not only find out last digit, you can find out last 2 as well. We'll see this in the next section, but for the time being, just visualize this. Okay, so what did we understand from this section? What are you supposed to know from this? 2, 3, 7, 8 have a cyclicity of 4, all the red circle. 4 and then 9, blue circle, have a cyclicity of 2. After every 2 power, the unit digit gets repeated. And 5 and then 6 have a cyclicity of 1, which means 6 raised to anything, the unit digit will always be 6. 5 raised to anything, the unit digit will always be remaining to be 5. Okay, so after understanding this basics and after knowing the cyclicity of each one of this number, now let's apply everything that we have learned. Now how do we get the problems in exam with respect to the concept of unit digit that we have learned till now? So now let us apply everything that we have learned with the basics of unit digit. So now the question that is being asked to me is, what will be the unit digit of this number? 123 raised to 123 into 456 raised to 456 into 789 raised to 789. Now imagine how big this number would be. 123 being multiplied 123 times. How big number this will be? 123 into 123 itself is a 5-digit number. 123 into 123 into 123 multiplied 123 times. Similarly, 456 multiplied 456 times. 789 multiplied 789 times. If I do this entire multiplication now, this big number into this big number into this big number, okay, obviously the board will be filled that much how big the number would be, the multiplication of this 3. What is actually the unit digit of that number is my question to you. So how will you start solving this? For that you need to visualize a basic. So if I ask you a simple question as 12 into 12 into 12, that's a simple question. What is a unit digit of this? So you know that is 12 cube. So 12 cube is what? 1728. We all know that. But I am not asking you the answer for this. I am asking you only what is a unit digit of this. That is 8. So can I get this unit digit by any shortcut? Of course, you will say the unit digit of the first number, that is 2. Multiply by the unit digit of the next number, that is 2. Multiplied by the unit digit of the next number. 2 into 2 into 2, that is equal to 8. So I get the unit digit here. So in short, no matter how big the number is, if I ask you the unit digit of that number, you need to just take what? The unit digit of the first. So you will tell me what is the unit digit of this number. You will tell me what is the unit digit of this number. And you will tell me what is the unit digit of this number. Then you multiply the 3 unit digit to get to your final answer. That's what you did it here. 2 into 2 into 2. So I need to find out only the unit digit of this number. I don't care what that number is, because I just want to know the unit digit of this. Okay, that's what my simple logic here is. So let's find it out now. This is 123 raised to 123. This could be written as 3 raised to 123, correct? Because it is one and the same thing. This is 3 raised to 123. I need to find out only the unit digit. Now what do I understand from this? As soon as I see a 3 here, what is the cyclicity of 3? The cyclicity of 3 is 4, which means what? I'll divide this number by 4, something that we have learned earlier. Then I find out the remainder. What is the remainder here? Check it. 4 what? 4 5s are 20, correct? 4 5s are 20. Remainder here is 3, which means this is equivalent to 3 raised to 3. 3 raised to 3 is nothing but 27. It has a unit digit of 7, which means what? 3 raised to 123, which is nothing but 123 raised to 123 is going to have a unit digit of 7. That's what I get it from here. So I got the unit digit of first number, that is equal to 7. Okay, similarly you will find out the unit digit of this. This is 6 raised to 656. Only see the unit digit. 456. I said 656, 456. Now 6 has a cyclicity of what? 1, which means 6 raised to anything, I'll always get my unit digit as 6. So 6 raised to 456, the unit digit for this will be 6. So I got the unit digit of second number as well. Now let's go on to the last number and find out what is its unit digit, and we reach to the final answer then. This is 789 raised to 789, which I can write it eventually as 9 raised to 789. So I can write this as 9 raised to 789. Now 9 is a cyclicity of what? 2. So I'll divide this by 2. I'll get my remainder. My remainder turns out to be as 1. Okay, only divide the last digit. 9 divided by 2. 2 4s are 8. Remainder here is 1. Which means this is similar to 9 raised to 1. 9 raised to 1 ends in a 9. So will 789 raised to 789, that is nothing but 9 raised to 789 will end in a unit digit of 9. So I get the unit digit here as well as 9. Or else you could have solved it directly. Odd power, 9 raised to any odd power will give you 9. Okay, you can directly get from that logic. No need to do any of this, because 9 is a cyclicity of 2. That is why it is important to remember the cyclicity, because you want to solve this sum in exam in just 20 to 25 seconds. For that you need to remember the cyclicity. That's what I get now. Finally 7 into 6 into 9. So what will I do? 7 6 it is 42. What is remaining is 42 into 9. 9 into 2 it will be 18. That's it. 8 will be my final answer. Okay, no need to solve this. You can solve this. 9 into 2 18. 9 4 is 36. 378 will be your final answer, but you only need the unit digit. So 9 into 2 18, 8 will be a unit digit, and that's your final answer. So 123 raised to 123 into 456 raised to 456 into 789 raised to 789. This has a unit digit of 8, which means if you multiply all of them, no matter how big the number is, I don't care for the number, but the unit digit of that number will be 8. And what is the simple logic that I use it here? If you want to find out any unit digit of any bigger number, it has to be what? Unit digit of this into this into this. Now how can I change this problem? I can change this problem just by putting a plus here. Instead of an into, I put a plus here. That's the only change I am doing it. Instead of an into, I put a plus here. So what will you do? You also put a plus here. You also put a plus here. So if I put a plus, what will be the answer? 7 plus 6 now. That will be what? 7 plus 6 will be 13 plus 9. 13 plus 9 will be what? 22. Unit digit will be 2. Unit digit will be 2. Okay, so what are you supposed to do? Just find out the unit digit of the individual number, and whatever is the sign between them, perform that operation to reach to your final answer. So that's how you will be tested with the concept of unit digit in the exam. So the next question that I ask you is, what is the unit digit of this number? And the number given here is 6 raised to 223 into 253 raised to 121 into 747 raised to 782. And I need to find out what is the unit digit of this entire number, which means all the three numbers are being multiplied. As we know the logic, what will you do it here? You'll find the individual unit digit. You'll find first the unit digit of this, then you'll find the unit digit of this number and this number. Multiply the three to get to the unit digit of this big number. Okay, as we can visualize, 6 multiplied 223 times, 253 multiplied 121 times, and 747 multiplied 782 times. How big this number will be if I multiply all of them now? All of them with each other, how big this number will be? What is the unit digit of this number? Okay, so all that I need is first the unit digit of this. 6 raised to 223. Now what is the cyclicity of 6? 6 raised to anything. We have learned this. 6 raised to anything, the unit digit will always remain to be 6. So 6 raised to 223, the unit digit here will be 6. Got it, the first part. Then this 253 raised to 121 could be written as 3 raised to 121, because all I need to find out is a unit digit. So I'll look out only for the unit digit here. Now as soon as I see 3, I understand that 3 has a cyclicity of 4, something that we have learned in the earlier part of the class, which means whatever is the power, I'll divide that by 4 and I'll get the remainder from here. What is the remainder that I get it from here? 4 5s are 20. The remainder here is 1, which means 3 raised to 121 is similar to 3 raised to 1. 3 raised to 1 ends in a unit digit of 3, which means what? 3 raised to 121 will also end in the unit digit of 3, and that's what I get it here. The unit digit of this part is 3 and the unit digit of this part is 6. Let's get the last part here. What is the unit digit of 7 raised to 782? So I write it here now, 7 raised to 782. What do I understand as soon as I look at this? Even 7 is a cyclicity of 4. So I'll divide whatever is a power that by 4. I'll see the remainder here. I'll divide only the last 2 digits because that is 4. That is what the divisibility test for 4 says. 4 20s are 80. What is the remainder? 2. So this is similar to what? This is similar to 7 raised to 2. 7 raised to 2 has a unit digit of 9 since it is 49, which means 7 raised to 782 will also have a unit digit of 9. So I'll write it here as 9 now. So what is the problem? Turned out to be 6 into 3, 18 into 9 is what I get it here. What is 18 into 9? 9 8s are 72. Unit digit here is 2 and the problem is solved. So that's why you have to remember the cyclicity of all the numbers so that you can get answer to such problem quickly. And the only concept that you require here is, if they ask you to find out the unit digit of big number, get the unit digit of smaller numbers, then multiply the unit digit to get the unit digit of the final big number. Okay, that is coming out to be 2 here. Now as I did it in the earlier problem, can I just replace this into by plus? This is how also the problem can be made. I can just replace this into by plus. Then what will happen? You will also put a plus here. So then what will be the answer? If it was plus in all this case, what will be the answer then? 6 plus 3 9, 9 plus 9 18, unit digit 8, and that's your final answer to this, unit digit 8. Okay, in case they put a plus here. So all that you have to do is find out the individual unit digits, and whatever is a operation that is being given between the two unit digit, perform that operation as into or an addition and reach to your final answer. So after unit digit, we start with the concept of last 2 digits. Okay, and I ask you the question as, tell me the last 2 digits of these numbers. 3 raised to 4, 9 raised to 2, 3 raised to 720. All red circles are with the unit digit of 3. All the blue circles here are here with the power of 9, 9 raised to 2, 9 raised to 820. Green circles are here with the power of 7 raised to something. So 7 raised to 2008. And 137 raised to 64, so 7 is also here. And I have one distinct number which is 1 raised to 126. What will be the last 2 digits? Okay, so now I'm not asking you the unit digit, I'm asking you the last 2 digits of these numbers. So how will I start with this? Let's start with a simple problem and understand a pattern here. 3 raised to 4. What is the last 2 digits of 3 raised to 4? What are the last 2 digits? 81. Right? I know 3 raised to 4 is nothing but 9 into 9. 9 into 9 is 81. It has only 2 digits. So the last 2 and the first 2, everything will be 81 here. 9 square. What will be the last 2 digits? Simple. Again 81. It has only 2 digits. 81. So last 2 will also be 81. Very simple. If I come to this now. 11 raised to 126. Now I have to decode this. I need to find out the last 2 digits of this number. 11 raised to 126. Can you think of a unit digit for this now? I don't know last 2, but I at least know the unit digit of this. This number will obviously be very big. Okay, I don't want to know the entire number. Just tell me the last 2 digits. That's what the question is. Imagine 11 being multiplied 126 times. How much big the number will be? What will be the last 2? So what will be the unit digit here? Since this is 1. Okay, 1. What is the cyclicity of 1? 1. Which means 1 raised to any number. 1 raised to 1 crore also, the unit digit will be what? 1. 1 raised to anything, the unit digit will be 1. Okay, we had studied this in the previous class. I told you about 5 and the 6 having a cyclicity of 1, but so will 1 have the cyclicity of 1, right? 1 raised to anything, the unit digit will always be 1. Now how do you get the tens digit? Now there is a logic that you can apply to this. What is the logic? This digit, whatever is this digit, now will be multiplied by the last digit of this. So you will have to now multiply 6 into 1. And what is 6 into 1? 6. That you will have to keep it here. So the last 2 digits will be 61. In short, if I have to give you a generic formula for the numbers ending in 1, what are you supposed to do? See, if this much big is my number, I have to find out only the last 2 digits of this. So what do I have it here? I have some number, big number. Tens digit I have it as x. Unit digit I have it as 1. And this number is raised to say n. Okay, then what will I do? If this number is raised to n, 1 multiplied n number of times, the unit digit will always be 1. But the tens digit is equal to this into this. It is equal to n into x. And that's what I did it here. Since this was 1, it remained to be 1 here. And the tens digit is n. But then this is a 3-digit number, 126. So I just take the last digit of this. 6 into 1. 6 into 1 is 6. And that is my final answer here. Or else you can say 126 into 1 is 126. What is the unit digit? 6. That is what I'll put it here. So this is n into x, the unit digit of that. The unit digit of n into x. Okay, and that's what gives me the final answer. So in case I ask you this now, 21 raised to 432. Tell me what is the unit digit and the last 2 digits. What will be the unit digit of this? 1. Okay, what will be the tens digit of this? This last of this, which is 2. 2 is being multiplied by 2. 2 into 2 is nothing but 4, and that 4 will come here. So the last 2 digits will be 41. If I ask you what is 71 raised to 8, 3, 9, 5, 6, what will be the last 2 digits of this? So if it is ending in 1, and you can apply this trick to only the numbers who are ending in 1. Okay, so please make a note of that. Only to the numbers who are ending in 1 you can apply this trick. Nowhere else. So I took only the numbers starting from this, then moving on to this, now solving this. All these 3 are ending in 1, and that's only when I can apply this trick. So since the unit digit is 1, I'll put the unit digit here as 1. Tens digit, what will I do? The last of this 6 being multiplied by this. 6 sevens are 42. Unit digit here is 2. So I'll put a 2 here, and the problem is solved. The last 2 digits of this number are 21. 2 and then 1. Okay, so that's how simple it is to get to the last 2 digits if my number is ending in 1. So in the last video we saw the trick of how to find out the last two digits of the number if the number is ending in 1. Okay, अगर number 1 में end हो रहा है तो last two digits कैसे find out करना है मुझे पता है. Now how will I find the last two digits of these numbers 7, 3. Okay, अब इनका कैसे find out करेंगे. So ये तो 1 में end नहीं हो रहा है क्योंकि ये 3 और ये 7 है. We will make them end in 1. We'll make them end in 1. So 3 और 7 को somehow we will adjust their power to make them end in 1. क्यों ऐसा कर रहे हैं हम, क्यों उनको 1 में end कर रहे हैं? Because we have a trick to solve and get the last two digits of the number ending in 1. 3 और 7 तो 1 में end नहीं हो रहा है, बट हम पावर ऐसे एडजस्ट करेंगे कि हम उसको 1 में end करवाएंगे, क्योंकि अगर वो 1 में end हो गया then it is easier for us to reach to our solution, क्योंकि फिर हम वो 1 वाला ट्रिक अप्लाई करेंगे और अपना आंसर लिखेंगे. ओके, सो लेट्स स्टार्ट विथ 3 raised to 720. इससे स्टार्ट करते हैं. 3 raised to 720. अब क्या करना है मुझे इसमें? looks a good number but I need to make sure that it ends in 1. so 3 का कौन सा power ends in 1? 3 raised to 1 is 3, 3 raised to 2 is 9, 3 raised to 3 is 27, 3 raised to 4 is 81. so 3 का power 4 ends in 1. जैसे ही I understand that, I know that अब 3 का power 4 एडजस्ट करते हैं. so I write here as 3 raised to 4. 4 raised to what? 18. 4 ones are 4, then this is 4 ones are 4, 32, 4 8s are 32, 180. That's what I get it from here. 3 raised to 4 raised to 180. ऐसा क्यों लिखा? क्योंकि 3 का पावर 4 ही मुझे 1 देगा, तो उस थॉट प्रोसेस से ये आया. अब 3 का पावर 4 क्या होता है? What is 3 raised to 4? 3 raised to 4 is nothing but 81. We all know that 9 into 9 81. So the problem is now reduced to 81 raised to 180. This is my problem right now. 81 raised to 180 आ गया. ओके, ये 3 raised to 720 1 में एंड नहीं कर रहा था, तो मैंने उसको 1 में एंड करवाया. क्या चेक करके? क्या 3 का कौन सा पावर मुझे 1 देगा. सो 3 का पावर 4 मुझे 1 देता है, सो ऐसे एंड करवाया. अब इसका आंसर तो मुझे पता है. 81 raised to 180. व्हाट आर द लास्ट टू डिजिट्स ऑफ दिस? क्योंकि ये 1 है, ये 1 रहेगा. ये हो गया मेरा यूनिट डिजिट. टेंस डिजिट के लिए क्या करेंगे हम? इसका लास्ट क्या है? 0 being multiplied by इसका second last. 0 into 8, answer will be 0. So the last two digits of 3 raised to 720 will be 0, 1. And there we go, the problem is solved. Okay, वैसे हम और कौन से नंबर के लिए कर सकते हैं? 9 के लिए भी कर सकते हैं हम ये चीज़. कैसे? इसको 1 में एंड करवाते हैं. 9 को 1 में एंड करवाते, तो दिस इज नथिंग बट 9 raised to 820. अब क्या करना है? ये सोचना है कि 9 का कौन सा पावर 1 में एंड होता है. 9 raised to 1 is 9, 9 raised to 2 is 81. इट मीन्स 9 का पावर 2 1 में एंड होता है. सो अब 9 का पावर 2 लेके आओ यहाँ पे. सो यू विल राइट दिस एज 9 power 2 raised to 4. what? This is 240s. Okay, 2 not going 0. Okay, and 5. 405. 2 4s are not going 0. 405 into this is 410. Okay, 410. My bad. 410 double is 820. Correct. So that's what I write it here first. Okay, then what will I see it here? 9 power 2 is nothing but 81. So I'll write it here as 81 raised to 410. Then what? Problem is solved. Since this is 1, unit digit will be 1. How will I get the tens digit? I know how to solve 81 raised to 410, right? This is the trick of 1 that I'll apply it here. So if this is 1, this is 1. Tens digit is what? 0 into 8. The last multiplied by the second last. 0 into 8 will be what? 0. So the last two digits of 81 raised to 410 is 01, which is nothing but the last two digits of 9 raised to 820 is 01. So what did I do in case of 3 and then 9? I made them end in 1, and that's how simple it is to reach to the solution of such problem. Now next time whenever you get any number, try and make them end in a 1. Okay, and then you just apply the trick for ending in a 1, क्योंकि हमें सिर्फ जो नंबर 1 में एंड होते हैं उनका ही लास्ट 2 डिजिट्स फाइंड आउट करने आता है, तो बाकी सबको 1 में एंड करवाओ. So in the previous video we learned how to find out the last 2 digits of number ending in 1. Unit digit will be 1 and the tens digit is last digit of the power multiplied by the second last of this, right? We know the technique. If the number does not end in 1 for 3 and then 9, we make them end in 1. How do we make them end in a 1? 3 power 4 makes 3 end in 1 and 9 power 2 makes 9 end in 1. Okay, so only thing we do here is make the number end in 1 and then apply the trick of ending in 1. So we'll make here now 7 raised to 2008 end in 1. Okay, and then we apply the trick of ending in 1. Okay, so I need to find out the last 2 digits of 7 raised to 2008. So make it end in 1. Now first thing that you will have to realize is which power of 7 gives me 1. 7 raised to 1 7, 7 square 49, 7 cube is again ends in 3 and 7 raised to 4 is 49 into 49, it ends in 1. So 7 power 4 ends in 1. So I'll write this as 7 power 4 raised to 502. Why am I doing this? Because only 7 power 4 ends in 1 and that's what I want to do, make it end in 1. Now I can write this 7 power 4 as 7 raised to 2 into 7 raised to 2 raised to 502. What is 7 raised to 2? 7 raised to 2 is nothing but 49. So the problem is now reduced to 49 into 49 raised to 502. Okay, now what is 49 into 49? This is what you have to understand. We have solved this by base method. Now you can solve this quite easily, but I want you to know the base method because that will be applied to this as well as this problem. So understand what is this. Those of you who are done with the mental calculation class, awesome, you will be knowing all of this trick. And those of you who are not done with the mental calculation class, please go through all of them so that you understand this shortcut well. Now, in case you want to avoid that class, you want to be in this class, this is just a short summary of how do you find the square by base method. Now see, if I ask you to find out 102 square, I need to find out 102 square. So I'll take my base as 100. There are 3 base, 10, 100 and 1000. This is close to my 100 base. So I'll take my base as 100. Since this is 2 more than 100, I'll add 2 to this. I'll add 2 to this. So this becomes, now add this, 102 plus 2, this becomes 104. 2 into 2 I multiply, I get the answer here as 4. But I'll write here as 04. Why? Because my base is 100, it has 2 zeros in it. I needed a 2-digit number here. That's how you solve the square. So in case I give you 106 square, how will you solve this? You will say 100 will be my base and this is 6 more than 100, so I'll write it here as plus 6 and plus 6. Then you add this 106 plus 6, this will be 112. 6 into 6 will be 36. That is your answer, 11236. Similarly, if I ask you to find out what is 48 square. So for this you will take the base as 50. But you don't have a base as 50, you have only 3 base, 10, 100 and 1000. So you will derive the base as 50 from the primary base of 100. How do you do that? Divide 100 by 2. That's what we have learned, right? Now I derived the base as 50. Now this is 2 less than 50, so minus 2 and minus 2. 48 minus 2, it will be 46. 2 into 2, it will be 4, but again I will write it as 04 because I need a 2-digit number. Why do I need a 2-digit number? Because I derived from the primary base of 100. It has 2 zeros in it, so I need a 2-digit number. That's what we have learned comprehensively in a good 2.5 hour class of Vedic maths and mental calculation. This is the concept that we'll use it here now. What will be applied here? This is 49 into 49. How will I solve this now? 49 into 49. I'll say my base will be 50, just like this. But there is no such base as 50. I'll derive the base as 50. How? 100 divided by 2, because these are only my base. Got the base as 50, now solve. This is 1 less than 50, minus 1, minus 1. 49 minus 1, this becomes 48. 1 into 1, the answer here is 1, but I'll write it as 01. Why? Because I derived it from the base, primary base 100, it has 2 zeros in it, so I needed a 2-digit number. I know all this. Now how will you get the LHS? What operation did you perform to get your secondary base? 50 base कैसे मिला? 100 divided by 2 करके. So LHS पे वही operation perform करोगे, divide by 2. 48 divided by 2, the answer is nothing but 24. 2401 is my answer. What am I telling you here is you don't need to find out what is 49 square. You know if it is 49 square, अगर 49 square है, so मैं -1 लिखूंगा. Why will I write -1? Because I'll assume my base to be as 50. If I write -1, I surely know that the last two digits that I'll get here is 0, 1. I don't care for what this number is because this is not required. So no need to do any of this calculation. You can solve this sum in 15 seconds. You have to see 49 into 49. Last two digits will be 0, 1. Why? Because I'll write -1. I'll need a 2-digit number. 50 will be my base. So 0, 1 आ जाएगा and this will be 502. All that you will have to do here is now just multiply. Did it end in 1? Yes, it ended in 1. How did it end in 1? We made it end in 1 by adjusting the power of 7 as 4. क्योंकि ये 1 है, so unit digit हो जाएगा 1. Tens digit will be what? The last digit of this multiplied by the second last 2 into 0. 2 into 0 is what? 0. So 0, 1 will be the last two digits of your number, which is 7 raised to 2008. Okay, so all that we applied here is made the number end in 1. So we get it here. The power of 9 is 2. That ends in 1. The power of 3 is 4. 3 power 4 ends in 1. And the power of 7 is also 4. Which can make 7 end in 1. So remember this, 7 power 4 ends in 1, 3 power 4 ends in 1, 9 power 2 also ends in 1. Now let us take a big number and try to get the last two digit of that. So now we start with 33 raised to 128. अब इसका कैसे find out करेंगे हम? So let's start it here. 33 raised to 128 is the number that I have it now. First of all, I have to make it end in 1 because that is where I have a trick. So 3 का what power can make it end in 1? 3 power 4. 3 power 4 can make it end in 1. So write it at 33 raised to 4 raised to 4 what? 4 3s are 12, 4 2 side. 32 into 4 is 128. That's what I do by adjusting the power. Why did I adjust it to be the power of 4? Because that can only give me 1. Now I'll write this as 33 raised to 2 into 33 raised to 2. The whole thing is now raised to 32. That's what I get it from here. Now you will say that still it is very easy, right? I'll have to just get 33 square, multiply them and reach to the answer. Correct. You have to get a 33 square, which will be a 4-digit number. From here also you will get a 33 square, which will be a 4-digit number. You'll have to multiply this too, and this whole thing is raised to then 32. Then you get some, once you multiply this into this now, you will be getting some good 8 to 9 digit number, which will end in a 1. Okay, then you can apply the trick of ending in 1, and that's how simple it will be. Okay, but my question here is, why do you need to do so much of calculation here as well? Only thing I need here is the last two digit. So let me just think from the last two digit point of view only. I will not care what is the digit here, and then here. I only care for what are the last two digits of 33 square. Okay, so let's just find that out now, and that is quite simple. Just the base method that we applied it in the last problem. 33 into 33. I'll take my base as 50, so I'll do minus 17 minus 17. 17 square is 289. 2 will go as a carry, and the last two digits here will be 89. I hope you remember the Vedic maths calculation class that we did it here. Only two digits remain here, rest everything go as a carry. So 89 will be here, and 89 will be here as well. Now I just need to multiply last two into last two to get the last two of this. Okay, looking little confusing? No, not at all. See, if you multiply this 4 digit and this 4 digit number, you will get this 1 2 3 4 5 6 7 8. Say you will get a 8 digit number. The whole thing is raised to 32. I am saying I don't want to calculate this 8 digit number. I just need the last two of this, because this is where I have work with. Last will be 1, so unit digit will be 1. Of course it has to be, because that is how I adjusted my power. What is this digit is the only thing I want to know here. So why do I need to do so much of calculation is my first question here. So what will I do? I'll just multiply last two into last two. In case you are imagining how is this happening, now multiply. See, 123 into 123. Okay, if you multiply this, we had learned this in 3 by 3 calculation. How do you do that quickly? So the answer for this will be 15129. 15129. But I am telling you, I don't want to know what are the first 3 digits. Just tell me the last 2 digits. So you can say, okay, this is 123 into 123. Just multiply the last 2 into last 2. 23 into 23. 23 into 23 is what? 529. 529. So 5 will go as a carry. 29 will be the last 2 digits. Correct. Which means if there is a big number, say 1, 2, 3, 4, 5, 6 into 1, 2, 3, 4, 5, 6. What will I do? If I just want the last 2, just multiply last 2. 56 into 56. And you will get the last 2 digits of the multiplication of 1, 2, 3, 4, 5, 6 into 1, 2, 3, 4, 5, 6. I don't want to know the big number. I don't want to know the big number, however big this is. I want to know the last one. That's what I did it here. A 4 digit number multiplied by 4 digit number. You will get an 8 digit number. But I just want the last 2 of that. So I'll just multiply last 2 of this into last 2 of this. So eventually now I multiply 89 into 89 to get the last 2 of this. Okay, the same logic that we are using it here. 89 into 89. Now if I take my base as 100, I'll do here minus 11 minus 11. What is 11 square? 121. 1 will go as a carry because only last 2 digits remain here. 21, which means that 89 square, the last 2 digits are 21. I didn't even find the entire 89 square. I just found out the last 2 digits, that are 21. Now my problem is solved. Since this is 1, unit digit will be 1, and the 10th digit is this last digit into this second last. 2 into 2, 4. 41 are the last 2 digits of 33 raised to 128. Okay, just so to put it as a summary, what did I do it here? I first saw this is 3. I need to make it end in 1. 3 power what will make it end in 1? 3 power 4. So I wrote it here 3 power 4. This became 33 square, 33 square. I don't need to find out this entire number because I just need the last 2 of this. So I applied the base method. 17 will be at the right. So 17 square 289. I found it orally. 89 into 89 hoga. Now I no need to multiply this 4 digit number into 4 digit because I need the last 2 only. So just multiply last 2 into last 2 to get the last 2 of this. The logic here is this. 123 into 123. Number is this big, but if I want just the last 2 of this, just multiply 23 into 23. Similarly, if you want 1 2 3 4 5 6 into 1 2 3 4 5 6, you don't want the big number when you multiply this. You just want the last 2 of this. So 56 into 56, and that's what I'm doing it here. Just multiply 89 into 89. You will get the last 2 of this. So 89 square. Again I use the base method. Minus 11, since this is 11 less than 100. So last 2 I realized will be 21. If last 2 will be 21, unit digit remains to be 1. 10th digit will be last into second last. 2 into 2, 441. Okay, I think now the only confusion that you may be having is how am I using this base method. Okay, for that you will have to see the class on mental calculation, because there are many such tricks like that which are being shared in that class, and if you know that, solving such problem becomes a lot easier. Now let's come and see this problem on last 2 digits, which is 137 raised to 64. Now how do I find out the last 2 digits of that? Okay, so let's start it here. 137 raised to 64 is what I have here. So I understand it is nothing but 7 raised to 64. So what power of 7 will make it end in 1? Okay, because first of all I need to make this end in 1, and then I can apply my trick for ending in 1. So which power of 7 ends in 1? 7 power 4. We have already seen this. Okay, so I'll write this as now 137 raised to 4 the whole raised to 16. Okay, and why did I do this? Because now it can end in 1. 7 power 4 will end in 1. Now from this I get this as 137 square into 137 square, correct. Okay, the whole is being raised to what now? 16. Now 137 square will be a good 6-digit number. Okay, I just want the last 2 of that. Into again this 137 square will be a good 6-digit number, but I just want the last 2 digits of that. So I will not solve this. This whole thing is raised to 16 now. I will only get the last 2 of that. So how will I solve this? Now this is where the Vedic maths calculation chapter comes into the picture. If you have not seen that, there is a good chance that this may go as a bouncer, but I'll try to explain as much as possible in this short session on this last 2 digits. So we need to find out what is 137 square. What are my base? 10, 100 and 1000. 137 square, so I'll write this as plus what? 37 into 37. Okay, whatever is the LHS, I don't care. I just need the RHS, so I need the 2 digits here. It will be 2 digits. Why? Because my base here is 100, it has 2 zeros in it. I will only have a 2-digit number here. What is 37 square? Whatever is a 37 square, the last 2 digits of that will be remaining here. Now to find out 37 square, I will take my base as 50 now. How will I take the base as 50? I will derive the base as 50. From where will I derive? I will derive it from my primary base, which is 100, because I have only 3 base, 10, 100 and 1000. So from 100, I divide 100 by 2 and I derive my secondary base as 50. Now since I have a base as 50, I will write this as minus 13 minus 13. If I do it in this way, this will be what? 13 into 13, 69. Which means whatever is 37 square, I don't care. The last 2 digit of that will be 69. The first 2 will go as a carry, right? Because only 2-digit number remains here. But the last 2 will be 69, which means 137 square will have a last 2 digits which are 69. So this will be 69 and this will be 69. So the problem is now reduced to 69 into 69. What is the logic for that? We just saw it in the previous problem. If it is 123 into 123, okay, whatever is the answer, the last 2 digits will be what? 29. And how do you get this? Last 2 into last 2, right? 23 into 23 is 529, and that's what you get it here. So whatever big is this number, how many digit that number would be? Say 3, 4, 5, 6, 7. Say it is 11-digit number. But I just want to know what are the last 2 digits of that, and that entire thing is now raised to 16. So last 2 will be last 2 of this multiplied by last 2 of this. So eventually I need to find out what is the answer for 69 into 69. Again I will take my base as 50. Secondary base as 50. I derived this, divide by 2, 200. If I take base as 50, I will write this as plus 19 because this is 19 more than 50. 19 square is 361, which means 3 will go as a carry. I always have 2 digits here. That's my rule. Okay, because primary base was 100, it has 2 zeros in it. That's why I will always have a 2-digit number. So 61 is what I get it here. 61 will be here. 61 will be here. If 61 is here, now my problem is solved. If the unit digit is 1, this has to be 1, and the 10th digit will be last of this multiplied by second last of this. 6 into 6. 6 into 6 will be 36. So the unit digit will be 6. So the last 2 of this will be 61, and the problem is solved. Okay, so all that you have to do here is see the number, make the number end in 1, and if you are multiplying a 4-digit number into 4-digit number and you need only the last 2, so just multiply last 2 into last 2 to get the last 2 of the multiplication of 2 4-digit numbers. So no need to find out that 8 or 9-digit number at all. You can solve this problem in a minute in the exam if you know the basics of base method and Vedic calculations. Okay, so having said this, this is how you always go ahead by finding out the last 2 digits of any number raised to any number. But now there is a problem. We only know to find out the last 2 digits of the number that can end in 1. So we can make 9 power 2 end in 1. We can make 3 power 4 end in 1. We can make 7 power 4 end in 1. What about the numbers which don't end in 1? Like say 2 raised to 282. You cannot make 2 end in 1 at all. Okay, so what for that number? In that case, if the number is not ending in 1, if no power of the number is ending in 1, then how should I go ahead and solve such problem? We'll see this in the next part of the class. Let us now come into the last section of finding the last 2 digits. As I told you earlier, if the number is not ending in 1, no power of the number ends in 1, then how will you solve it? Because till now we know only the trick of the number ending in 1. How do you get the last 2 digits of that? What if the number or any power of that number does not end in 1, which is 2 raised to 105? You take 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4. None of the power of 2 ends in 1. So what will I do now? So for that you need to know certain basic, and the first basic that you're supposed to know is 2 raised to 20. What is the answer for 2 raised to 20? 2 raised to 20 is nothing but 1048576. What is the meaning of this? If I multiplied 2 20 times, 2 into 2 into 2 into 2, such that 22s if I multiply, I'll get this number. What is important for me here is what are the last 2 digits of this number. The last 2 digits of 2 raised to 20 is 76. That's what I need to understand. 76 are the last 2 digits of 2 raised to 20. After that, you need to know one more thing here. 76 raised to anything. 76 raised to anything. This anything means any number. Raised to 1, raised to 2, raised to 3, raised to 4, raised to 5, raised to 1 lakh. The last 2 digits will remain to be as 76. You want to try this? Try 76 raised to 1, 76. 76 square, last 2 digits will be 76. 76 cube, the last 2 digits will be 76. 76 raised to 4, last 2 digits will be 76. So 76 raised to any number you put it here, last 2 digits will always be 76. That is a property of 76 here. Okay, so having known these 2 things, let's start solving the problem. This is what you're supposed to know even before we start with the problem. So I'm being given here now 2 raised to 105. What will I do here? I only know what is 2 raised to 20. That's from where I'll start this problem. So bring this in terms of 2 raised to 20. How can I write this as 2 raised to 20? I can write this as 20 raised to what? 25 it is 100. Correct. What is left is now 2 raised to 5, right? 2 raised to 5 will be left here because this is total is 105. A raised to m into a raised to n is equals to what? A raised to m plus n. That's laws of indices. So 25 is 100 plus 5, 105. Now what do I know? I know this is 2 raised to 20. So what will be the last 2 digits of 2 raised to 20? 76. Correct. I'm not writing the big number. As you know, I'm just playing with the last 2. So last 2 will be 76. So this number now reduces to 76 raised to 5 into 2 raised to 5 is what? 32. So write it here. Now this is 76 raised to 5. 76 raised to anything, the last 2 digits will be what? 76. Correct. I'm just not writing the entire number. If you can visualize, 2 raised to 20 is a big number. I just wrote the last 2 of that. 76 raised to 5, big number, but I just wrote the last 2 of that, 76. 76 is now being multiplied by what? 32. And now the problem is over. You just have to multiply 76 into 32 and tell me what are the last 2 digits of this multiplication. It will be a 4-digit number. Just tell me the last 2 digits and that will be my answer. Now there is a shortcut to this as well, in case you want to solve it by shortcut in the exam. Of course you have to solve it by shortcut, because this is 76 is a magical number. 76 multiplied by any power of 2, any power of 2, which means what? 76 is being multiplied by 2 and any power. Any power means it could be anything. 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4. In this case it is 2 raised to 5. So in this case it is 76 into 2 raised to 5. that is 32. The answer is always the power of 2. The last two digits will always be the power of 2. So 76 into 32, the last two digits will be 32. In case you want to check it, just multiply. 76 into 32 is what? First multiply that. 76 into 32 is 2432. It's 2432. But what do I know? The last two digits are 32, which is nothing but this only. Similarly, if I do 76 into any power of 2, so say I am doing 2 raised to 4. What will be the last two digits? That only. That number itself will be 2 raised to 4. 16 will be the last two digits. If I do this 76 into say 2 raised to 6, that is 64. The last two digits will be what? Whatever is here. Whatever power of 2 you multiplied. 64. That will be the last two digits. Okay, that is the power of 76. It multiplies any power of 2 and gives you the last two digits at that same power of 2. So if it is 76 into 32, the last two digits will be 32, and that is my final answer to this question. Okay, so what did we understand from this? We understood that first of all I need to get 2 raised to 20, last two digits 76. 76 raised to anything, last two digits will be 76, and 76 multiplied by any power of 2, the last two digits will be that power of 2 as an answer. Okay, now let's explore few more questions in the next videos and understand this method even better. So after 2, let's come on to 4. Now I need to find out what are the last two digits of 4 raised to 80. Okay, so what do I know for this? Two things that I know: 2 raised to 20 and 76 raised to anything. So I'll make this end first in 2. So I'll write this as 2 raised to 80. So 80 into 2 is what? 160. So the problem is now reduced to 2 raised to 160. What do I need? I need the power of 2 to be as 20. So I'll write this as 2 raised to 20 raised to 8. Okay, 20 into 8 is what? 160, and that's what I know about it. Now 2 raised to 20 is a big number. I don't want to know the number, but what are the last two digits of that? So even if I write the entire number 1048576, no need to write this at all. But what are the last two digits of that number? 76. So the problem is now being reduced to 76 raised to 8. 76 raised to anything. 76 raised to anything. The last two digits will be what? 76, and that's your final answer. So the last two digits of 4 raised to 80 are 7 and 6. Let's now apply the same thing to 6. Now I'm being given as 6 raised to 80. Now there is a problem. Why? Because there is a 6 here which is made up of 2 and a 3. So I'll split this 6 as 2 raised to 80 into 3 raised to 80. Okay, in case you are wondering how did I do this, very simple. 2 into 3 raised to 80, this is 6 raised to 80. Now taking this 80 inside, 2 raised to 80 into 3 raised to 80. Now I will have to solve this by 2 raised to 20 method, and I'll have to solve this by one method because this is 3 now. I'll make 3 end in 1 and I'll solve this by the trick of 1. But this LHS I'll solve it by the trick of 2 raised to 20. So I will have to merge both the methods that I have learned to solve for 6 because it has a 2 as well as a 3 in it. Okay, so let's solve it now. I'll write this 2 raised to 20 as 2 raised to what? 20. 2 raised to 20 raised to what? 4. I want 2 raised to 20. Then 3. 3 power what? What ends in 1? 3 power 4. So I'll make 3 power 4. So I'll write this as 3 raised to 4 raised to 20 because I want it to end in 1. Now if this is 2 raised to 20, the last two digits of that number will be 76. So the problem is now being reduced to 76 raised to 4 into 3 raised to 4 is 81. 81 raised to 20. Now I have to solve this. Now since this is what? 76 raised to anything, the last two digits will always be 76. If you are able to imagine, I am not writing the entire number, just the last two of this and the last two of this. So 76 raised to 4, the number will be big. 76 raised to 4. But what are the last two digits of that number? 7 and 6. So I write only that. Into 81. 81 raised to 20 in itself is a very big number. But what are the last two digits of that number? In case you're not able to visualize something like this. This is the big number. 76 raised to 4, and so is your 81 raised to 20. All that I am writing here are the last two digits of that number, and eventually I'll just multiply them. So this is again a big number, but the last two of that are 76 raised to 4. Similarly, 81 raised to 20 is a big number, but the last two digits will be what? The logic of 1. If this is 1, this will be 1. 10th digit is 8 into 0. The last of this into the second last of this. 8 into 0, 0. 01. So eventually I'm left with this 76 into 01. 76 into 1 is what? 76. Right? 76 into 1 has to be 76, and that's my final answer. 6 raised to 80, the last two digits will be 7 and 6. So for 6 you have to use the method of both 2 as well as 3. Okay, now let's see the last number here, which is 5 raised to 567. We didn't see it for 5, right? 5, it is very simple. 5 raised to anything. 5 raised to anything. You know it. What are the last two digits? 25. So 5 raised to anything, the last two digits will always be 25. So don't worry about it. This is like the easiest thing that you can remember it here. Okay, so now what did we learn from this? We know a trick for number ending in 1, how to get the last two digits. For 3, 7 and 9, what do? We make them end in 1, and then we apply the trick of ending in 1. 3 power 4, 7 power 4 and 9 power 2 gives me 1. So that's what I'll do with that number. And for number where the power, any power that is being raised to that number, if it does not end in 1, for example 2, what do you do for that? You solve it by the logic of 2 raised to 20. 2 raised to 20 ends in 76. 76 raised to anything, last two digits are 76. Okay, and what is a basic thing that you need to understand here? If I am multiplying one 8-digit number by another 8-digit number, and I just need the last two digits of their multiplication, so I don't need to find out that 16 or 17 digit number. I can just multiply the last two of this 8-digit with the last two of next 8-digit number to get the last two of that 16-digit number. Okay, that's a simple logic that we have used to solve all the problem related to finding last two digits.